Hopefully you've seen that the organic compounds have a lot of variety in them. After drawing some of them, you can just keep growing them in terms of length by putting more and more carbons on, or you can start to branch off the sides, and there's a huge variety, and that's why they're so useful in terms of living systems, is that the different ways you can rearrange carbons with branches or not branches or having other atoms on that carbon chain make it very useful in terms of making molecules that are important in the human body or other, the biological world. What I'd like to do is just to introduce you that when you put oxygen into the chain, that it will then make classes of compounds that have special properties, which we'll talk about on each of those groups as you study them. But just recognizing what those we're called functional groups that create classes of families are is important. Now, oxygen can attach in two different ways. Oxygen has 6 electrons around it. From last week, we talked about those, and that means 2 places are willing to share. So it could, get 2 electrons from 2 different places, or add 2 different groups on it. A hydrogen and a carbon, for instance, is going to be the first example. Where an oxygen is just on the carbon chain and the hydrogen's on the other side, that's called an alcohol. As you can see, it's got an OH group, and you're just looking for an OH on any number of carbons. Could be in the middle, could be on the end. Now, because it can move all over, you should include a number in that system where that O is attached from the end, which carbon from the end is the OH group attached, and it ends with an OL name like alcohol, pentanol, ethanol, something. We'll name those more on a different worksheet. You're just going to learn what are the functional groups today so that you can recognize them and maybe draw some. Ether is the next one. Ether, like a diethyl ether, which is a great anesthetic and helps people put them to sleep when they were in hospitals, has an oxygen but 2 carbon chains, a carbon chain on both sides. So a carbon on one side, carbon on the other. And that helped to differentiate it from alcohol. All single bonded O's. Alcohols and ethers are just single bonded O's. But this one has 2 carbons on the oxygen. Now, when that happens, you'll get a compound that usually can evaporate even better, and that was something that would evaporate into our lungs, and that would help to anesthetize people. They had to be careful, though, because it evaporated so well, it would fill the room, and then if there was a spark or flame, it could catch on fire. All of these burn very well. That name is ether. So we'll practice these tomorrow, is you'll name the 2 side chains, like something methyl ether or something. Next one is an aldehyde. Aldehydes were great at preserving things. The most common aldehyde is called formaldehyde. It's a methyl aldehyde, and 1 carbon chain with a double bonded O. And it's when the double bonded O is at the end, that's called the aldehyde. If there's just an H next to the oxygen that the carbon's attached to, you'll know it's at the end of the chain. You can tell here, carbons, all of a sudden now there's just 1 more H. That's the end of the chain. That's an aldehyde. When the double bonded oxygen, though, is in the middle, there's a carbon here, and then there's carbons on both sides. That carbon where the double bonded oxygen is, that's called a ketone. Ketones are well known when you start to have health conditions called ketolysis. Some biological reasons that ketones become important when your body isn't processing some things right, diabetes and those kinds of areas, excess exercise. Ketones become important if you're studying those kinds of health fields. So ketones, when the oxygen is in the middle. So notice these had single bonded oxygens, these 2 have double bonded oxygens. Now, there's only one other way we can put oxygens on, is have a double bonded oxygen in one direction and a single bonded oxygen in another. And those are our last 2 groups that we're going to learn about. And again, just learning the families so that you can recognize them becomes important, so that you can appreciate, some organic chemistry. Just naming them is a tough piece, and so getting used to them. Where 2 oxygens are on, and that second oxygen that only has 1 bond has an H on the end, that's called an acid. Acid because that last H can come off and do some other work. Vinegar is a great example of acetic acid or ethanoic acid. The way they name those, and you'll learn that when we get to that day, is put oic acid at the end. Name of the carbons, and then the word oic acid. If the 2 oxygens on the same carbon have then another group of carbons on the end, just like the difference between ethers and alcohols, you had an H group on one was alcohol. Well, when the 2 oxygens are there, H group on it makes it an acid. When there's 2 oxygens on the same carbon, in the other side of the oxygen has more carbons, that's called an ester. Esters are cool because they have very fruit smells. They have, they're used in perfumes. A lot of times they're used for their smell and have very distinct sort of flavors. So that is going to be called an ester. Ester ends in the word 08. And we'll learn how to name those when you get to that. So that is the different kinds of families that carbons can have with oxygen. See if you can at least recognize those or draw a few based on these notes and what's given in line. Thanks.